Hello everyone, this is Chinnaiah Kalpana here. In this video, we're going to see a problem from partial differential equations. So let's get going. Problem: form partial differential equation by eliminating arbitrary functions from z equal to f of x plus 4t plus g of x minus 4t. So here we are given a relation or an equation, and we are asked to form a partial differential equation by eliminating these arbitrary functions g and f or f and g. So let's see. Given z equal to f of x plus 4t plus g of x minus 4t, right? Consider it as equation number 1. Now let's partially differentiate it with respect to x and also with respect to y. First, we'll partially differentiate it with respect to x. Partially differentiating 1 with respect to x. Just apply dou by dou x on both sides of 1. You'll get dou z by dou x equal to partial derivative of f of x plus 4t with respect to x is f dash of x plus 4t into inner derivative. That is partial derivative of x with respect to x 1 plus partial derivative of 4t, which is treated as constant with respect to x, is 0. Since we are partially differentiating with respect to x, so we'll treat t as constant. Here x and t are variables, okay? Plus partial derivative of g of x minus 4t is g dash of x minus 4t into its inner derivative. Partial derivative of x with respect to x is 1 minus partial derivative of a constant with respect to x is 0. And remember, here we are not going to use any of these notations, okay? This gives us dou z by dou x, because here we are having x and t as independent variables, okay? Right. If we have y, you can just replace dou z by dou y by q, but here we have t, so we are not going to use any of the notations. Simply is equal to f dash of x plus 4t, 1 plus 0 into f dash, okay, 1 plus 0 is 1 into f dash of x plus 4t is f dash of x plus 4t, plus 1 minus 0 is 1 into g dash of x minus 4t is g dash of x minus 4t. Now consider this equation as equation number 2. Now let's partially differentiate 1 with respect to y. Partially differentiating 1 with respect to y. Just apply dou by dou x, dou by dou y on both sides of equation. Then we'll get dou z by dou y equal to partial derivative. Here we are partially differentiating with respect to y, so we'll treat, okay, here we have second variable t, right? We have to partially differentiate 1 with respect to t. We don't have y here, okay? So we'll get t here. Since we are partially differentiating with respect to t, so we'll treat x as constant, okay? This gives us partial derivative of f of x plus 4t with respect to t is f dash of x plus 4t into inner derivative. Partial derivative of x with respect to t is 0 plus 4 into partial derivative of t with respect to t is 1 plus partial derivative of g of x minus 4t is g dash of x minus 4t into inner derivative. Partial derivative of x with respect to t is 0 minus constant 4 into partial derivative of t with respect to t is 1, right? This gives us dou z by dou t equal to 4 into 1 4, 4 plus 0 4, right? 4 into f dash gives 4 into f dash of x plus 4t, right? 0, 4 into 1 is 4, 0 minus 4 is minus 4, minus 4 into g dash of x minus 4t is minus 4 into g dash of x minus 4t. Consider this equation as equation number 3. Now we are having dou z by dou x and dou z by dou t, right? Now we are going to find second derivative, that is dou square x by dou square z by dou x square and dou square z by dou t square. Okay, we need to find dou square z by dou x square. Just by differentiating both sides, partially differentiating both sides with respect to x, we'll get dou square z by dou x square. And by partially differentiating equation 3 with respect to t, you'll get dou square z by dou t square. Okay, we need to just apply dou by dou t on both sides of this equation. Simply, we'll partially differentiate equation 3 with respect to t to get this second derivative, dou square z by dou t square. Okay, let's see that also. Now we'll partially differentiate 2 with respect to x. Okay, partially differentiating equation 2 with respect to x, then we'll get dou by dou x of dou z by dou x equal to, okay, the RHS part, dou by dou x of the RHS part, RHS part of 2. This gives us dou square z by dou x square, right, equal to, since we are partially differentiating with respect to x, so we'll treat t as constant here. Fine. Now let's find the partial derivative of RHS part. Partial derivative of f dash of x plus 4t is f double dash of x plus 4t into inner derivative, that is dou by dou x of x plus 4t. Let me write. I already skipped this step, right? Showing the derivative part of RHS. Now partially differentiate g dash with respect to x. Partial derivative of g dash is d double dash into inner derivative dou by dou x of x minus 4t. This gives us dou square z by dou x square equal to f double dash of x plus 4t into partial derivative of x with respect to x is 1 plus partial derivative of a constant with respect to x is 0 plus g double dash of x minus 4t into partial derivative of x with respect to x is 1 minus partial derivative of a constant with respect to x is 0, right? This gives us dou square z by dou x square equal to 1 plus 0, 1. 1 into f double dash is f double dash, that is f double dash of its double dash, okay, x plus 4t plus 1 minus 0, 1. 1 into g double dash is g double dash of x minus 4t. Consider as equation number 4. Now let's partially differentiate 3 with respect to t. Partially differentiating 3 with respect to t. Fine. Now just apply dou by dou t on both sides of equation number 3. You can do directly, but it is always good to apply dou by dou t on both sides. Okay. This gives us dou square z by dou t square equal to constant 4 into partial derivative of f dash with respect to t is f double dash of x plus 4t into inner derivative, that is dou by dou t of x plus 4t minus constant 4 into partial derivative of g dash with respect to t. G dash is nothing but g dash of x minus 4t, okay? G double dash of x minus 4t into inner derivative, that is dou by dou t of x minus 4t, right? This gives us dou square z by dou t square equal to 4 into f double dash of x plus 4t into partial derivative of x with respect to t. See, here we are partially differentiating with respect to t, so we'll treat x as constant. So partial derivative of a constant with respect to t will be 0 plus this constant 4 into partial derivative of t with respect to t is 1, right? Plus, sorry, you have minus, right? At minus g4 into g dash of g double dash. This gives us partial derivative of x with respect to t is 0 minus 4 into partial derivative of t with respect to t is 1, right? This gives us dou square z by dou x square, sorry, it's t, dou t square equal to 4 into f double dash of x plus 4t into 4 into 1, 4, 4 plus 0, 4, minus 4 into g double dash of x minus 4t into minus 4 into 1 is minus 4, 0 minus 4 is minus 4, right? This gives us dou square z by dou t square equal to 4 4s are 16 f double dash of x plus 4t minus 4 into minus 4 plus 16 into g double dash of x minus 4t. Consider as equation number 5. Fine. So we got dou square z by dou t square equal to 16 f double dash plus 16 g double dash. Now observe the equations 1, 2, 3, 4, 5. Okay. So if you notice clearly, we can say that from these two equations we can get the required partial differential equation. So let's see, because here we have f double dash plus g double dash, here also we have some constant into f double dash plus some constant into f double dash. By looking at these two equations, we have to just imagine that if we take 16 common, you can get 16 times f double dash plus g double dash, which can be replaced by this equation, right? I mean this value, otherwise whatever. You have to just observe the equations and finally decide what and how you'll get the partial differential equation. Okay, fine. Now let's see. From 5, or we have 5, dou square z by dou t square. I'm just picking equation number 5 simply, or we have equation 5, okay, equal to 16 f double dash of x plus 4t plus 16 g double dash of x minus 4t. What I'll do is, I'll just take 16 common from these two terms, okay. I'll get equal to 16 times f double dash of x plus 4t plus g double dash of x minus 4t, right? Fine. Now from equation 4, what we have? We have f double dash of x plus 4t plus g double dash of x minus 4t equal to dou square z by dou x square, right, by 4, since by 4. So what we'll do? We'll just replace this by dou square z by dou x square. Then this becomes dou square z by dou t square equal to 16 into, replace this term, replace this by dou square z by dou x square, right? This gives us, or we can write this equation as 16 into dou square z by dou x square equal to dou square z by dou t square, right? Now bring this to LHS, you'll get 16 into dou square z by dou x square minus dou square z by dou t square equal to 0, which is the required partial differential equation. Right? Fine. Therefore, 16 into dou square z by dou x square minus dou square z by dou t square equal to 0 is the required partial differential equation. This completes the problem. Well, we have seen a problem from partial differential equation in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.